Okay, so the warm-up today was once again a review on simplifying radicals. And we've talked about there's not just one correct way to do it. There are many ways we can do it. As long as we follow the rules, we should get the right answer. Now, I'm always looking for the easiest way. And for me, I see that 15 and 30 have a common factor of 15. So what I would have done was multiplied the -2 and the 3 and got -6, and then rewritten the 30 as 15 times 2. And then without making it a large number, which 450 is not bad, and I know that 225 goes into 450 twice, that still wouldn't have been bad. But this way, I don't even have to think of big numbers. I can see the 225 here. The square root of 225 is 15. And so 15 times -6 is -90. Okay?
Did you say -90 or -9?
-90.
Oh, okay, good. I thought it was equal to stuff.
Okay. Number 2. Square root of 24, the largest perfect square that is a factor of 24 is 4. And the largest perfect square that is a factor of 54 is 9. So the square root of 4 is 2. The square root of 9 is 3. And this gives me 14 roots of 6 minus 9 roots of 6 is 5 roots of 6. Any questions about number 2? They were like radicals. I can combine them. Okay, number 3. Now, I would have simplified the denominator first. You may have multiplied through on the top and bottom by square root of 12. You can still get to the correct answer that way. I just like to work with smaller numbers. So I would have simplified the square root of 12 as 2 roots of 3. So what I would be working with is 2 plus the square root of 3 divided by 2 roots of 3. So I cannot have this radical in the denominator, so I'd multiply the numerator and the denominator by the square root of 3, which gives me a term that I must distribute through the numerator. So 2 times the square root of 3 is 2 roots of 3, and 2 times square root of 3 times the square root of 3, what happens when I multiply the square root of 3 times itself? It becomes 3. And 3 times 2 is 6. So when I do this times this, I get 6.
I have a question.
Yeah.
Did you add an extra 2?
Did I add an extra 2?
Yeah.
Oh, I did. I'm sorry. Sorry.
I didn't know where you got that.
I thought I was going crazy.
Thank you, Kyle.
You're welcome.
I appreciate that. Sorry. Well, down here you get 2 square roots of 3 times 3, which is?
3.
3 times 2 is 6. There we go. That's where it is. It wasn't up top. Okay, so we would probably write this 3 plus 2 roots of 3 over 6.
These are not my best ones.
That's why we're going to keep doing them. Okay, now in second period, somebody didn't see the plus, and they worked this problem.
Yeah.
And I was like, ooh, that's a good problem. Let's work that one too then.
That's what I did.
So if you didn't see the plus, which we can't ignore the plus, but if we, if we had this problem instead of this problem, what would we do? Well, you could think of it as this. Can we think, is that fair? Does everybody see how those are the same thing? And then we could say 3 goes into 3 one time, and 3 goes into 12 4. And I know the square root of 1 is 1, and the square root of 4 is 2. And when I multiply reciprocals, I always get 1. I was like, oh, I wish I had made that problem. I like it when the answer turns out neat like that.
On what?
Wait.
But you're doing something.
Oh, wait. That's equals.
So I said if I had given you this problem instead of this one. Now, are we allowed to ignore a plus sign?
No.
Never. That's right. No. Okay? All right. Let's move on. Homework. You start checking. I'm going to go check Evans now that he's back.
Evan, yeah. Go Evan. Nope.